Is it recording to? It's recording somewhere. That's fine. Okay. So recall that because the arc length along the unit circle corresponds exactly to the radian measure, we can use the circle itself as a number line when we're using it for input values for trig functions. So when we graph sine and cosine is basically taking coordinates on the unit circle and plotting them onto a coordinate plane. It's like unraveling the unit circle when you graph a sine or cosine graph. So just some terms to make sure we're comfortable with, and then we'll just talk about key points. We'll talk about how the sine and cosine graphs look. So cycle is basically, well, cycle and period are kind of the same thing. I'm trying to understand what's meant by that. Well, a period is the length of one cycle. That I know. Periodic function is a function that repeats itself. I'm not sure how to define a cycle. It's just a cycle. I don't know what's meant by that. I mean, I could just show you a graph. I guess that might help. That's one cycle, right? So, yeah, I guess I can call it a repetitive pattern. I think you guys know what this term means, so I'm just a little at a loss why these are in the notes. But again, I didn't make these notes. I just borrowed from the previous teachers. So anyway, we know those terms. Amplitude, I do know. That's the height. From the midline to the peak. So this would be an amplitude. Right? That's the amplitude. Does that make sense? Okay. Key points. We have 5 key points. So the 5 key points will be start, end, and 3 middle points. And they're all spaced equally. Sorry for my messy handwriting, it really sucks. But spaced equally, right? That makes sense? Remember when we found the starting ending points when I did 31, 32, 33 with you guys the other day? We had the start and ending points, and then how did I get the 3 middle points? I partitioned them equally. I went halfway between start and middle. Sorry, start and end. And then I went middle of the start and middle, or middle of the middle and the end. So I just partitioned equally 3 partitions in the middle, right? All right, let's keep moving. Graph of sine x. Keep it really simple. Let me zoom out a tad. Here we go. Perfect. This is exactly how I want it. So it looks like this. I'll do 2 cycles. What the heck? All's good. Domain, what's the domain, guys? All real, totally, 100%. What's the range? Inclusive, good. Period's 2 pi. Odd symmetry. Because sine negative x is negative sine x. That's an identity, right? Also, if I rotate 180, do I get back to the same configuration? If I have the ors as my pivot points, yeah, okay. X-intercept, there's a whole bunch of x-intercepts. I'll say it's n pi, where n is any integer. And the y-intercept, of course, is 0, 0. And let me write that as a ordered pair. The x-intercepts n pi comma 0, where n is any integer, right? So n could be 2, 3, 4, 5, 1, 0, -1, -4, -5, whatever, right? So that's a good generalization. We're gonna use the letter N a lot in this class too, because it's or K. We can use that also or whatever, but I like to use N. Okay, all's good. Yeah, let's keep moving. Let's keep on moving. Absolute max and min. Absolute max value is 1. Absolute min value is -1. The 5 key points, 0, 0, pi over 2, 1, pi, 0, 3 pi over 2. Remember, it's all unit circle stuff, right? 3 pi over 2, -1, and find 2 pi, 0. So it goes middle, high, middle, low, middle. Actually, what the heck? I'll write that down as well. Middle, high, middle, low, middle. Okay, go ahead. Oh, sure. I mean, well, yeah, I mean, well, then you're writing as a cosine then, right? Because if you're starting at the peak or low point, that'd be a cosine graph. Any discontinuities? Any breaks in the graph? Any asymptotes? Nope. It's a nice, clean graph. Very smooth. It's continuous. All right, so move on to cosine. Cosine looks like this, right? Starts at the peak, goes here, 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 here. Yeah, it's actually pretty good doing freehand with the mouse. Okay. Domain, is it still the same? Yep. Yep. Range still the same? Yep. Period, still the same. Symmetry is different though. It's even. See how the y-axis cuts it in half, right? Also, that's because f of -x is just f of x straight up, right? If I like do cosine of 3 pi over 4, it's the same thing as cosine of -3 pi over 4. X-intercepts, y-intercept, we'll just get that out of the way. That's 0, 1. Max value is 1, min value is -1. Duh, you know that. X-intercepts, how do you think I could write that? What do you think would be an appropriate way of writing that? Okay. Okay. Okay, good. But what is n going to represent? Be careful.
All odd integers.
Yes, thank you. Much better. If you said all integers, that wouldn't have been quite correct. It would be too inclusive, right? N is any odd integer. And we're really going to have to do some other advanced trig problems down the road this semester, like solving trig equations. We're going to have to use we're going to have to use n to represent general solutions, and we're going to have to be somewhat creative with what n represents. You know, that will happen. We'll get there. But in this case, does that make sense? Why n's any odd integer, right? Okay. Yeah, it can't have even because then it would then include pi or 2 pi, and those are not x-intercepts clearly from the graph. Okay. So cosine and sine are very, very similar, except for the x-intercepts and except for the symmetry. Everything else is, and of course the y-intercept too. Everything else is pretty much the same, right? So why do we call why is it first of all, how are they related? How are cosine like how are they different? I guess that's a better question. Sean, go ahead.
They're shifted.
By how much? Exactly. And that's where the word co comes from. Co is short for complementary. You guys remember complementary angles from geometry? What do complementary angles represent in geometry? 2 out of 90, exactly right. So if you have like sine of 30, same as cosine of 60. If you have sine of 20, guess what? That's cosine of 70. So they're the same thing. Actually, I think on the ACT and SAT, anyone taking the ACT tomorrow, by the way? Not tomorrow.
Saturday.
2 days from now, Saturday, yeah. Yeah, they sometimes ask those kind of questions. They do some trick stuff. And you know, like they might have to do that whatever complement situation. So more things we have to say here, really just get them out of the way. No discontinuities, no asymptotes, key points 0, 1, pi over 2, 0, pi comma -1, 3 pi over 2 comma 0. I know this is very redundant, but I just want to just be consistent here, right? Consistency is good. 2 pi comma 0. No, 2 pi comma 1. Sorry. So it does this, right? High, mid, low, mid, high. So high, mid, low, mid, high. That's what cosine does. How can you obtain the graph of cosine from the graph of sine? Shift by pi over 2 in either direction. I mean, well, no, it would just be a negative. Yeah, it's still a cosine, just be a negative. Yeah. If you shift to the right, it's positive cosine. Shift to the left, it's negative cosine. Right. But in either direction, it's still a cosine graph. So if you're confused, let's just go to Desmos, right? Desmos is our best friend. Oh, actually, let me show you this to you as well. Do you guys know how to change the scale on Desmos to make it look like in terms of pi? Okay, you're gonna learn. I'm recording it. See that little monkey wrench there? That's a toolbar. You get to choose what you want for x, right? It's your choice. Let's go from -2 pi. And how do you type pi in? Yeah, there we go. You don't have to use that little keyboard. That's a waste of time. 2 pi. Okay, but it's still, it doesn't, fine. It went from -6.28 to +6.28. It doesn't do in terms of pi. Force the issue. Let's say I want them separate. How wide do you want each tick mark? Like maybe pi over 2 units? Yeah, let's do pi over 2. There we go. Done. There you go. So you got it done for you. So y equals sine x. Okay. So if I do y equals cosine of x minus pi over 2. Oh, yikes, sorry. I meant to put minus. My apologies. Pi. There we go. Notice it's the same exact thing, right? If I do plus, like it does shift, but still, what if I make that negative sign? Now the same thing, right? So if I shift it left, it's like a negative sign. If I shift it right, it's like a positive sign. So it's still the same thing. Either direction. That's why I said either direction. Just the amplitude would change, or the A value would change. All right. All right. Transforming graphs. Okay. We talked about this as well, but this is where I really want to kind of slow down a little bit, pump the brakes a little bit here. So here's what I'm going to do. This is the technique I like to use. I want to figure out where I should start, where I should end. Then I want to do partitions. Bless you. And then graph. Keeping in mind vertical changes. Kyle, do you mind closing the lights, please? Just so people can see a little better. I know it's a glare. That's the fan. So the top right on the right panel. Yeah. The top two. Yeah. And the one more top right or yeah. Thanks. Appreciate it. This is what I like to do. Figure out where to start the graph, figure out where to end the graph, partition, and let's graph. But keep the vertical changes in mind. So if you think about it, the 1/3, that's a transformation, right? So what does that do horizontally? It stretches it, right? By a factor of what? So if the period was originally 2 pi, now the period is going to be 6 pi, right? Or period could be 2 pi over b. So 2 pi over 1/3, which is 6 pi. So, but did we shift horizontally? Was there an h value? No. So when I say h value, what I mean by that, I should actually show you guys the general form. Generally speaking, we tend to think of graphs like this: a times sine bracket b x minus h plus k. We tend to think of it like that. Or replace sine with cosine. Okay. So I start at 0 and a 6 pi. Great. Now let's partition. 3 partitions equally spaced. What's halfway between them? 3 pi. It's a little tricky with the fractions. Yeah, you guys know. I'm going to sneak it in here. I don't like it, but whatever. Okay. Is there an amplitude change? Yeah, 2. Is there a vertical shift? Nope. All right, let's just plot it, So sine. Wait, what is this confusing or not? Okay. So I'll make it less confusing?
You're talking about how like the first number.
Oh, of course, right. No, I get that for sure. Yeah.
You still lost that. Partitions, man.
Partitions, the extra points in the middle. Yeah. So because you start and end, we need 3 more in the middle. Right. So yeah, we're good. Period I got. Amplitude I got. That's 2 and 6 pi. So I'm not really using the cloud method. I'm just really just thinking to myself, hey, what's my period? Where I start and end, do my partitions, think the vertical changes of mine, boom, 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 done. Got the graph. Right? All right, let's keep moving. Questions? We're good? Looking back, how can you get the graph? How you get the period and amplitude from the equation? Well, duh. It's right there. That's A. That's 2 pi over 1/3. I just showed that to you guys, right? There you go. Easy peasy. But amplitude, always state it as a positive value. Amplitude is always positive. Or the absolute of A. Think of it like that. Okay, A-okay? All right, let's keep track of time. Let's keep moving. Go to 11 o'clock. All right. Alrighty. So yeah, A is the amplitude. The absolute value of A, mind you. And 2 pi over B is the period. We know this, okay? And we assume B is greater than 0. Otherwise, it's kind of weird. I mean, you could make it negative, I suppose, it would reflect about the y-axis, but we usually don't do that. Okay, let's graph another one. All right. So, period. What is it? Amp2, is it? What is it? Good. Okay, start. Is there any horizontal shift? No. So we'll start at 0. Where am I going to end it? Pi. Pi. Okay, and then I'll do 1, 2. Partition. Pi over 2. Pi over 4. And what's the other partition, guys? Yeah, it's just hard to write it, but 3 pi over 4. Okay, it's cosine. Does cosine start in the middle or does it start at a peak or a low point? But because it's negative, we're going to start at the low point, right? You are right. Sorry, my apologies. Thanks, my apologies. Good looking out. That was careless. There we go. Right, we're good. So it shouldn't be this complex thing. As long as you know your transformations really well, you should be good. Okay, ready to move on? All right. Okay, translations or shifts. What happens when you add or subtract value from the function? So let's talk more about that. For example, how does this compare? Pretty obvious. 5 left and 3 down. Right? Does that make sense? 5 left, 3 down. But what if you have like horizontal, vertical stretches or shrinks? That can get a little crazy sometimes. So here's what we'll do. Here's how I'm going to approach it. For example, 3. I am going to take a look at this, right? Because that's the angle. 2x minus pi over 3 is the angle. That's the input. So I'm going to deliberately set that equal to 0. And solve for x. And also deliberately set it equal to 2 pi. Or don't need to do that necessarily. But if I set it equal to 0, what does x equal? Right. Another way you could approach this as well. What if I factor out 2? What does a pi over 3 become when we factor out 2? Just like dividing 2. What's pi over 3 divided by 2? Thank you, Sebastian. Pi over 6. So that's a transformation of pi over 6 right. So that's where you start. Now, where do you end? Well, what's my period? Pi. So I have to add pi to pi over 6. So where do I end? At 7 pi over 6. Okay. What's halfway between pi over 6 and 7 pi over 6? Or 4 pi over 6. Let's do 4 pi over 6 for now. And then, because the fractions are getting kind of messy, let's not worry about stating those other coordinates. But know that there's 2 other points, right? We know that. They're getting a little messy. I mean, you have to convert these to 12, like 2 pi over 12, 8 pi over 12, then you have 5 pi over 12. So, I mean, if you're curious, that is 5 pi over 12. And that would be, give me a sec, 11 pi over 12. If you were to state those extra partitions. Because if you think about it, you can increase the denominator, but you have to increase the numerator as well, right? Maybe 2 pi over 12, 8 pi over 12, 14 pi over 12, 5 pi over 12, 11 pi over 12. Okay, we're almost there. What's my midline? 1. How high am I going to go above it? So I'll go up to 4 or down to what? Perfect. So I'll do a little dash line here. And I'm going to start it at sine. So I'm going to start it at the midline. And it's positive A. So I'm going to go up, then down, not down, then up. That didn't get reflected. So I have a point here, a point here, a point here, and a point here. Notice I'm being incredibly consistent with my approach. I'm not like, oh, let's just try this or try that. No. Figure out where you start, figure out where you end, partition, use the vertical changes to do the graph. Boom, boom, boom. You got it, right? So you have a chance to practice this in the homework. State, blah, 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 whatever. Okay, well, that's not hard. That was 3. That was pi. That was pi over 6. And that was 1. And when you keep it positive, the assumption is going up or right, or negative going left or down. So that's all. I guess we should be more explicit. 1 up, power 6 right. The term phase shift is sometimes used for trig. That's because you're dealing with waves. Like waves can be in or out of phase. Everyone's taking physics. Well, you probably haven't got there yet, but because sine cosine, they're called sinusoidal curves. They're wavy, and waves have these things called being in and out of phase. That's where the term comes from. It comes from physics. Same thing as horizontal shift, just so you know. We refer that usually for sine and cosine, but okay. Okay, I'm not going to graph that again because I don't feel like it. But the question is asking, how can you get the four characteristics from the equation itself? Well, that's your amplitude. That's your vertical shift. P equals 2 pi over b. And to get the horizontal shift, it's a little tricky, but it's going to be pi over 3 divided by 2, which is why I prefer this format, as I already wrote earlier on. Vertical shift, period, amplitude. That's a horizontal shift. Some people memorize it like as H over B, or some people use the letter C, C over B. Honestly, just pull that B out, that X minus H, that H is your horizontal shift. Pull that 2 out, X minus pi over 6, you're good. Cosine works the same exact way. No different. Okay? I'll kind of wait because I know you guys are still jotting stuff down. Let me erase the board.
I'm so busy. Of course, yeah, go for it.
Okay, we're cool? We're good? All right. So it brings us to the following, this stuff here. So vertical shift again, they're using the letter D. I like using K, but just, D represents the vertical shift. And when you're solving this stuff here for the horizontal vertical shifts, that start, that's end. I already said that. That's what we do. You set the insight equal to 0 and 2 pi. But really, I just said equal to 0, find my period, and add that period to the starting point. That's what I like to do. So we're going to try this again for example 4. Excuse me. Okay. Let's try this again. Ready? Okay. Here's what I'm going to do. Let's factor out the pi. -3 times cosine. Pull that pi out. X plus 3. Cool. All right. So where am I going to start the graph? Yeah. And what's my period? 2. So where am I going to end it? Yeah, you don't even have to even go through that whole process of solving. It's pretty obvious. Okay. So we're going to start at -3 and at -1. We have some partitions. And is there any vertical shifts? Amplitude's what? Good. The midline's at the x-axis. It's negative cosine, so it starts below. Get to the middle, go high, back to the middle, go low, done. Right? if you want to verify, plug in -3 for x. That's gonna be cosine of 0, which is 1. -3 times 1 is -3. You're probably gonna say, that's like -3/2. Add that to 3 pi, that'll be 1.5 pi, which is -1. -3 times -1. Sorry, let me do that. That was 0. My apologies. That's 0. That makes sense. But putting -2, I get cosine of pi is -1. But -3 times -1 is +3. Amplitude's easy. 3. Period's easy. That's 2. Phase shift is -3. Vertical shift is 0. Right? All's good? All right. Let's hold off on writing the equations from the graphs. Let me save that for another time, because homework won't be on that. Let's talk about cosecant. Let's talk about secant. And I'll see if I can sneak a tan and cotan. And then I think we've closed the loop at this point. Okay, here we go.
Yeah, like.
All right, guys, let's fill this out. Quiet down. All right. So sine of 0, 0. And if I just fill this out, that's going to be I'll say 1/√2 for now. That's true. That's 1. 1/√2, 0, -1/√2, -1, -1/√2, and 0. So cosecant will require flips, right? A bunch of flips. Undefined. 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 1, -1. √2. √2. -√2. -√2. So I'm gonna have vertical asymptotes. Let's get a brighter color. So you have vertical asymptotes at 0. At pi. You guys do cosecant graphs last year? Did not. Oh, this is new. Okay. Okay. All right. So I'm doing asymptotes because it's undefined at those places. Now, if I plot pi/4, what's √2 roughly? Yeah, 1.4, right? And pi/2, 1. And 3 pi/4 also √2. Then here, 3 pi/2 is -1. 5 pi/4 is -√2. 7 pi/4 is -√2. The curve's going to look like this. And you can kind of use the sine graph as a crutch. And the blue curve, of course, is cosecant. Okay, we'll pump brakes a little bit. I know I went fast with all the other stuff. The cosecant graph is really just graphing sine. It really is. Graph like sine. The only difference is that you're going to draw these parabola things above and below. That's all there is. See how the red curve is kind of the foundation of the graph? And what am I doing? The light blue curves are going the opposite direction. as they should. It's a reciprocal sign, right? Think about it. What's the y value on the top of the red curve? It's 1, right? What's reciprocal 1? 1. What's the low point? -1. Reciprocal -1. -1. And 1 is the highest y value. -1 is the lowest y value. All the other y values are in between. The fractions, right? Like, for example, at 30 degrees, what's the sign of 30 degrees? No, pi over 6 is the radius, but what's the sign of pi over 6? Other way. 1/2. It's okay, you're mixing it up. What's the reciprocal 1/2? So that's what it should be like. So see over here, that's probably correlating with 30 degrees, right? Now in the calculator, what if you use sine of like 0.1? I know it's kind of weird, but if you use sine of a super small number close to 0, it's gonna be a super small fraction. What's 1 over a small decimal, small fraction? A big number. So that's what's going towards infinity. It becomes a vertical asymptote or infinite discontinuity. Let's actually explore this in Desmos. Right, let's switch this to sine x. Let me clear my drawings. Okay, what's happening as x gets lower, y gets closer to 0, right? Like I said, like what if I have 0.096, right? What's 1 divided by that y value? If I do 1 divided by 0.09895, need a calculator. I had one, so let's look at it. Here we go. If I do 1 divided by 0.095, I get like 10.5, right? Well, let me graph cosecant. Y equals C of CX. Yikes. Okay, so like 0.8, okay? I got 0.07991. 1 divided by 0.07991 is 12.5, okay? Yeah, there you go. Yeah, 12.5, right? So that's why that happens. Because you're taking all the y values on the sine graph and reciprocating it. And because all those y values are between -1 and 1 inclusive, you got a bunch of small decimal fractions that get flipped, causing that phenomenon to happen of those U shapes. Or they kind of look like they're not really parabolas, they look like parabolas. That's why that's happening. So that's what a cosecant does. Secant does the same exact thing, but just for cosine. I could graph the second cycle if you want me to. I mean, if I do it. So really what you do is, as I said, just graph the sine curve, right? Just do that. Sorry, I have it in the wrong place. That shouldn't be there. And yeah, just do this. And it's okay if you're a little sloppy about it. Because we'll transform later. But yeah, that's what you do. You just draw these little U shapes. Now domain and range those are interesting. Those are very, very interesting. Well, the range is from -infinity to -1, and from 1 to infinity. The vertical asymptotes are at x equals it seems like every pi value, where n is any integer. The domain, how would you say the domain? Yeah, I'm just trying to think the right way to say it. You could say all real except n pi, where n is any integer. Period's still 2 pi. Symmetry is still odd. That didn't change. So there are going to be some transformations that come with that. Questions? Let me show you a transformed cosecant before we do secant. I thought there was a okay. That's okay. Let me do example 3 for you guys, and then I think I'll stop there for today. Because I think that's a little too much for one day. I'm showing a lot of this stuff into you guys. So here's how to approach example 3. So think of secant like cosine. So cosines and sorry, secant and cosine are very similar. It's just that they're shifted, just like cosine and sine are shifted. So I'm going to do this. 1/2 times secant. Let's pull the 2 out. What does that become when I pull the 2 out? Minus what? Good. Awesome. Plus 3. Okay, where do I start? Lovely. What's my period? Where do I end? What, add pi to pi over 2, guys. Perfect. Good. Pi over 2. Partition. The middle is pretty obvious. What's the middle going to be? Pi, and then yeah, don't worry about the other ones, but you know, we know what they're going to be. All right. What's my vertical shift? And 1/2 is the amplitude. So my midline. All right. Now, I'm going to start it. It's like a cosine graph, right? That's what I said. Think about cosine for now. Then what you do is this. You look at wherever you cross the midline. And that, so asymptotes occur. Because if you think about it, actually, we should have actually did this.
What's halfway between pi over 2 and pi? 3 pi over 4. Okay, if I plug in 3 pi over 4 here, 3 pi over 4 minus pi over 2. What's pi over 2 converted to 4 as a denominator? 3 pi over 2 minus, sorry, 3 pi over 4 minus 2 pi over 4, which is pi over 4. What's 2 times pi over 4? Pi over 2, right? What's cosine of pi over 2? Well, it's reciprocal 0. Undefined. That's why we have an asymptote there.
That's why there's an asymptote. So then I just going to graph like this. And I know there's going to be another one right here as well. Actually, it's not terribly obvious. I'll just do this. I'll erase the middle. Middle's kind of a crutch. That's how the graph will look. It looks like that. So you graph like sine or cosine. Do it. But you're gonna have these like little U-shape things. Okay. Just to finish this off really quickly, we'll state hold on, why did I move? That was dumb what I just did. Hold on. Okay. Let me look at the homework. Let me see if homework asks for range. Give me one sec. Hold on. You know, it didn't ask for that, so yeah, actually it does. Okay. Can wait, Thomas? Almost done.
Yeah.
All right. Yeah, let's talk about domain and range really fast, because I know you guys can state, like, amplitude's still 1/2, right? Let's switch colors, let's go black. So amplitude, still 1/2. Period, still pi. Horizontal shift. Is still pi over 2. Vertical shift is still 3. Domain. Domain's a little tricky. Let's take care of range first. Range is actually easier. What would we say the range would be? Negative infinity to what? To 2.5. Union. From 3.5 to infinity. Domain. A little tricky. So 5 pi over 4 and 7 pi over 4. No. 3 pi over 4 and 7 pi over 4. My apologies. Yeah, so we actually should have found those. So it's going to be all real numbers except n pi over 4, where n is any odd integer. So that's what happens there. So if I look at the homework answer key, how did I express it? Kind of the way I did it. Yeah, for the most part. Okay. One thing I just realized, the homework includes sine, tangent, and cotangent, which I'm not going to do that in 6 minutes, guys. That's just not going to happen. So I'm going to adjust the homework a little bit. So the homework answer key may not be complete. So definitely I want you guys doing 38 and 40. So look in the homework. Definitely want you doing 30. Actually, we're not going to do 38 because I didn't talk about how to write the equation from the graph. So I'm going to, you know what? I'm going to adjust the homework. So probably we'll do 34, 35. We'll do 4 problems. I'll be a nice guy. We'll do 34, 30, yeah, 34, 35, 39, and 40. And you can check your answers in test. There's 4 problems. People are pretty simple. So the answer key may not make sense, but it's okay. I can still sign those problems next time. And that's that. We're all done.